All right. Good evening ulit mga engineers. Good evening. Welcome to another edition of Even Learning. For today, we will be tackling about air handling units or ACMV fundamentals. welcome, welcome. Welcome sa pagpunta ninyo. Welcome, Engineer Ruby Glenn, Engineer Eric. Welcome, welcome sa inyo. Thank you for giving me time, especially on this Saturday night. Sa mga hindi pa nakakakilala sa akin, ako nga pala si Engineer Gabriel. Let me share my screen with you guys. Oops. Oops. Uy, saan napunta yung share screen ko? There. Okay. So, again, this is the ACMV Fundamentals or ACMV Fundamental Series. Yung first yung first video natin is about psychrometric analysis last 30th of January. So now it's the 13th of March. We will be talking about air handling units. Next week we will be talking more about pumps and fans. Okay, so by the title itself, ACMV Fundamentals. So I'm not peddling or I'm not promoting any brand of AHU here, or nor fans nor pumps. So we will be talking about the fundamental principles behind this equipment, behind air handling units, fans, and pumps. So tonight we will be tackling about air handling units. Sa mga bago, sa mga hindi pa nakakakilala sa akin, okay, ako nga pala si Donnie Gabriel. So my name is Donnie Matthew Calpo Gabriel. I'm a professional mechanical engineer specializing in air conditioning and mechanical ventilation. I graduated from PUA 2001. I got my professional mechanical engineer license 2016. And last year, I finished my MBA from AMA University. I started my career as an ACMV design engineer under RJ Calpo and Partners, and then I started working overseas in 2005. I moved here in Singapore in 2009. So Singapore-based po ako. So my most of my work, most of my experience has been here in Singapore. So lampas 10 years na. So 12 years na, going 12 years na here in Singapore. If you have any questions or you have something to share, something to say, something to comment, or something to suggest, you can find me at evenlearning.sg@gmail.com. My handphone number, you can WhatsApp me, Viber me, call me, SMS me. Basically, reach out to me. My number is posted there on the screen. Okay. So again, we'll be talking about air handling units. Okay. So everybody can hear me, right? For tonight, we will be having 6 parts. So first is yung AHU modules, AHU filters, coils, fans, and economizers. So again, wala akong pinipedal, I'm not promoting any brand of air handling units. So what we're going to talk about will be common to all brands, common to all types of air handling units. Okay. So first, air handling unit modules. Okay. Air handling units is an encased assembly to perform one or more functions in distributing, cleaning, cooling, heating, humidifying, dehumidifying, and mixing of air. So by the title itself, air handling unit is something that handles air. It distributes, it sucks, it treats, it cleans the air for a specific purpose. Okay. So air handling units come in all shapes and sizes. So you can see there one of the brand names, Train. So it could be a long one, it could be a short one, it could be a tall one, it could be double decker tulad nito, double deckers, or single deck, and it could be vertical dito, or ito double deck pero magkaiba ng size. Or you can just have a simple AHU like this one here. So it comes in all shapes and sizes. No? It also comes with different stuff inside. So ito yung mga nakikita natin sa loob ng AHU. And we will discuss these modules and this function one by one. So each AHUs are divided into sections. So sections and modules. In each module, each section has its specific function for the AHU. Right. So first module or first function na patitignan natin is yung filter section. Okay. Okay. Filter section. So ito yung AHU, no? If you took out one of the panels, one of the side panels, this is what an AHU would look like. So here there are a few parts or few modules. Ang first module, ito, this is called the mixing box. Okay. This is where the fresh air and the return air would come in and mix inside this box. The second one is the filter section. So ito muna yung pag-uusapan natin. Ito yung filter section. So here, there are actually two kinds of filters installed here. There's one filter here, and there's one more filter here. Ano yung pinagkaiba ng filter na to at what this filters are supposed to do? Okay. Filters are actually divided into three specific purposes. So meron tayong orange, meron tayong green, meron tayong blue and purple. Okay. Ano-ano yung sabihin nun? So first, yung pre-filters, o ito yung G1 to G4, ito yung filter class. Itong column na to, ito yung filter class. Okay? And these types of filter or this class of filters are usually assigned to pre-filters. Ito yung itsura ng pre-filters, no? These pre-filters are usually, pag binuksan mo yung AHU mo, makikita mo, ito yung gawa sa karton. So, most likely, usually, these are disposable type filters. Madaling tanggalin, madaling ikabit, and i-dispose lang. Pero meron din syempre yung tulad nito, ito yung washable type filters. The washable type filters can be found usually sa mga fan coil units, sa mga small air cons, pero pag sa mga malalaking air cons, sa malalaking air handling units, medyo cumbersome na or medyo hindi na cost efficient yung lilinisin mo yung filter. Mas nakakamura na sila. Kung itatapon mo na lang, bibili ka na lang ng bago. So ito yung pre-filter. So how does this pre-filter work? Kung makikita mo dito sa sa filter class, may nakalagay siya G1, G2, G3, G4. Ano ibig sabihin nito? Itong G1, G2, G3, G4, it specify dito kung gaano kalaking particle ang kaya niyang tanggalin. So usually ito ang pre-filters ay low grade. Ito yung mga can only handle or can only capture yung mga malalaking alikabok. So yung mga nakikita mong alikabok, ayan, makukuha niya dito. Normal lang siya, normal disposable filter. So para ka lang naglagay ng handkerchief sa ilong mo. Kaya yun lang yung efficiency ng filter na to. And what makes it useful is it catches those big sized particles. And yung big sized particles usually yun yung pinakamadami, yung mga alikabok natin. And it's easily madaling napupuno o madaling napupuno ng alikabok. So kailangan tanggalin, kailangan palitan. Second filter ay yung bag filter. So balikan natin yung picture natin kanina, no? Let's look at our picture. So this is our AHU. So the pre-filter is actually this one. Okay? This one. This is a pre-filter. After the pre-filter, right beside it, immediately after the pre-filter, there's a bag filter. Why is it called the bag filter? Because it looks like a bag. So ito yung picture ng bag filter. Now this is the one. Bag filter. So the air that passes through here, where the coarse particles have already been removed, will be further filtered by this bag filter. So this bag filter will capture the air and further take out the smaller particles. These particles are usually small enough na hindi natin nakikita. So example ito yung mga smoke, yung mga amoy, yung mga may amoy, di ba, yung mga usok sa kung saan-saan, ayan, naka-filter na dito. So nawawala na siya, naka-capture na siya ng bag filters. Some people don't use bag filters anymore because you can see there's the depth of the filter is quite big. So sometimes they use these compact filters where the depth is actually smaller, but the efficiency is retained. The efficiency of the bag filters are retained. So una, of course, yung pre-filter natin, which will capture yung coarse particles or yung big particles, and then it will be followed up by the bag filters. So these bag filters will capture those smaller particles. And once the air passes through these bag filters, it's already clean enough for human breathing. Usually F9. So when you go to the AHU manufacturer, you would usually say, I want my pre-filter to be G4, ito, class filter, and my bag filters to be at F9. So you could also specify if you want on the normal bag filter or the compact bag filter. The efficiency would be the same. However, the length of the age of the filter will be shorter. So if you use this, your AHU will be shorter, but of course the cost of this filter is more expensive than this one. And the last one is yung N filters. So these are the special filters. So for example, you have a special cleanliness that you want to reach. So this is where your ULPA, your HEPA filter would come in. So N filters, bakit siya tinawag na N filters? Actually, tinawag siya na N filters kasi nasa end siya ng AHU. So ito yung picture natin kanina, di ba? This first one will be the pre-filters. The second one will be your bag filter. And the third one, the end filter, will be somewhere here after the fan. Ito pang susunod na picture natin. The next photo will show that. So this is the pre-filter. This is the bag filter. And these are your end filters. There you go. These are the end filters. So this filter now, opposite. This is the bag filter. This is the fan. This is the coil. And these are your end. Sorry. Baliktad yung gawa nung baliktad yung gawa nung AHU. These are the end filters. The fan should be the others, showing the other way around. So these are your end filter. Since we'll follow the AHU, we'll follow the AHU because the AHU configuration is the king. So on this configuration, these are the end filters. This is your pre-filters, your bag filters, and your end filters. So here on the normal configuration, this is your pre-filter. These are your bag filters, and your end filters would be somewhere around here after the fan. Okay. Bakit after the fan? Because these are the ones that have special functions. So the first filters were the pre-filters where they take out the coarse particles. The second one are the bag filters. Will take out the finer or the smaller particles, and the end filters are the one that's the ones that complies with your special requirements. Additional cleanliness, or sometimes the chemical filters are also end filters. Question regarding filters?
Sir Danny, good evening. Question,
yes,
sir?
Yes, sir.
Matanong ko lang kasi nakita ko tong end filter. Hindi ba yan mag-cause ng high pressure sa loob niyan, sir? Kasi karamihan sa AHU namin is walang end filter, which is clean room yung setting namin na sinaservice sa AHU. Yeah.
Short answer, yes. It will cause high pressure. Actually, yung mga HEPA filter at ULPA filter, matataas yung pressure drop nila. 200, 250 Pascal. So if you are sizing your AHU, you should be considering yung pressure drop ng end filters mo. Whether the filters itself are installed at your terminal unit or those filters are installed at the AHU. All right. If you
follow-up questions. Sorry, sir. Sige, sir. You can continue, sir.
If you put your end filters or yung HEPA for your case now, if you put your HEPA filters as part of your AHU, so your AHU manufacturer will consider that as your equipment internal static pressure. So you don't have to worry about that. But if you're going to put your HEPA filters at your terminal unit, of course, hindi yan kinonsider ng manufacturer, hindi yan kinonsider ni Daikin or ni Train or ni Carrier. You have to tell them, or you have to specify, or you have to indicate, or you have to add the pressure drop of your HEPA filter to your external static pressure requirement of your fan. Nasagot ko ba yung question mo, engineer?
Get it, sir.
Si Adrian yun, no?
Yes, sir.
Yes. Okay.
Follow-up question lang, sir.
Sige, sir.
Saan clean room setting kaya ito applicable, sir? Kasi yung sa amin, wala ganito, 100K, ISO 8. So, ito kayang N-filter, saan kaya ito applicable?
Yung depende sa ano, no? Depende sa requirement mo. So, I have different applications that are using N-filters. One application is yung food and beverages. So may clean room sila, no, 100K din. But they chose to put the N-filters doon sa room. Meron din naman ng pharmaceutical, yung mga operating laboratories ko, no. Ano naman sila, 10K. 10K yung requirement nila, and the N-filters are included doon sa AHU itself. Para pagka maintenance time, yung pagpapalit ng filters, wala sila doon sa loob ng operating room. So depende yan sa operation requirements, no? Operating requirements. So some clients want their N-filters at the terminal unit. Some clients want their N-filters at the AHU. So example, yung semiconductors, they don't have N-filters at their AHUs, no? They put it at the room itself. Meron silang fan filter unit. So doon nakalagay yung mga HEPA filters nila. So depende sa requirement ng client. As long as the pressure drop requirement of your N-filters are included in your calculation. Doesn't really matter where you put. Well, it matters where you put after the fan. After fan, hindi siya dapat mauuna sa mga pre-filter because your N-filters will become useless. So after nung big particles are captured, the smaller particles are captured. So pagtapos na nung fan, doon mo lalagay yung N-filters mo. But doesn't really matter if immediately after the fan or doon na sa terminal unit. Doesn't matter. As long as it's after the fan. Nasagot ko ba, Engineer Adrian?
Yes, sir. This is highly noted. Thank you.
Oh, thank you. All right. So, after nung filter, no? After nung filter, ang susunod na module, ang susunod na section ng AHU is itong coil. Okay? So, ito na yung coil section. So, dito sa coil section, may kita mo, this is where the heat exchange happens. The heat from the air is transferred to the water. This is where the portion where heat transfers from water and air comes into play, right? So this is a coil. Yung coil na to, if you take it out, this is what it looks like. All right. The coils, first, meron kang pipe header. So this is the pipe heading sa coil where water can transfer to first tube to the next, from one tube to the next. Depending on how many tubes, you would have how many rows of coil. So ito yung salansan ng coil, no? So the coil is parang yung sa kotse niyo is a radiator. All right? It's like a radiator. Wait a minute, let me just check. Okay, so let me just double check, no? I'm assuming everybody would be able to understand Tagalog because I'm switching from English to Tagalog. Just want to make sure na wala tayong kaibigan na foreigner. Anybody would require me to speak purely in English? Wala naman. Okay. So, okay lang ako na mag-Taglish, ha? So again, this is the coil. Yung coil kasi, meron siyang rows. Ito yung sa radiator, di ba? Meron yung mga tubo-tubo sa loob. So, depende sa pagkakasalansan ng tubo, yun yung coil rows mo, kung gaano karaming tubo ang kailangan mo. The more rows that you have, of course, the higher the cooling capacity of your coil. However, the more coils that you have, the higher the pressure drop of your coil also. So depende na naman sa pangangailangan ninyo, no? If you really don't bother much on how much the pressure drop, then how deep your coil is doesn't really matter. But if you are worried to your fan pressure drop, the fewer the coils, the lesser the pressure drop. Usually, the manufacturer will always size your coil at this inlet velocity. To have efficient heat transfer from your air to the coil, it is recommended to have a velocity near 2.5 meters per second. So if you would see your coil manufacturer's calculation, no, they would always have this 2.5 meters per second velocity through the coil. Okay, so to give you an estimated size of your coil, no, malapit sa katotohanan, you just get your airflow rate and you divide it into 2.5 meters per second. That would give you the phase area of your coil. Okay, if your velocity is lower than this one, you will have more heat transfer. But if you have higher velocity, you have less heat transfer. So yun lang yun, no? Your heat transfer will be dependent on your on your velocity. However, if you go with lower velocity, yes, you will get better or more efficient heat transfer, but your AHU size will be much bigger. If you want your AHU size to be smaller, you will have a faster velocity, but your heat transfer would not be efficient. So the manufacturers, looking for the middle ground, looking for the most efficient number, determined that at 2.5 meters per second, your AHU will be an optimal size, and you will still have an efficient heat transfer from your air to your water. So yung coils, no, meron siyang fins. Ito yung tubo na dumadaan, no? Tapos meron yung mga fins na ganyan. So kung makikita niyo yung mga aircon sa bahay, na yung mga window type, yun yung mga pinipisil sa likod. Tapos yun yung mga tawag ito, susuklayin. Ayan. Ito yun yung fins. The fins will determine the efficiency of your coil. Usually, these fins are 14 fins per inch. So 1 inch, no, if you measure 1 inch distance, no, of this fins, you would have 14 numbers of fins. So 14 numbers of fins will equal to will be sufficient for 1 inch of span. Okay. Sa coil manufacturing, no, there's 8 fins, there's 12 fins, and there's 14 fins. Okay. The lower the fins, the more heat exchange na naman ang mangyayari. The lower the fins, the lower heat exchange. The higher the fins, the better heat exchange. Kaso nga lang, kapag higher yung fins mo, ibig sabihin, higher din yung pressure drop mo. Pero mas maganda naman yung efficiency mo. If you lower the fins, you will have less pressure drop, but you will also have less efficiency doon sa heat transfer mo. So usually, no, pagka hindi ka nag-specify, unless you specify to your coil manufacturer, the default setting of your manufacturer, no, your AHU manufacturer, will be at 2.5 meters per second and 14 fins per inch. Ito yung default numbers. Unless you specify to them that I need this fins per inch, I need this velocity, ito yung ibibigay sa'yo ng AHU manufacturer ninyo. So at least you have an idea what size your AHU will be and how deep your coils will be. Okay? Okay. Isa pa, coils. Pag yung ilalim, this end cap here, this end cap here will be your pipe connection. The lower connection will always be inlet water. And the top connection will always be outlet water. So take note, pag nakakita kayo ng AHU, yung ilalim, laging inlet. Yung ibabaw, laging outlet. Okay? Wala lang tanong-tanong doon. Sa ilalim, inlet. Sa ibabaw, outlet. Bakit? Why it has to be inlet water be on bottom and the outlet water will be on top? Because when you fill in the coil with water, if you start with on top first, I'm sure that there will be other areas that won't be filled up with water and bubbles will be retained. And if you inject water from below, the water will fill up from below first and it will go up. You will ensure that you will be able to purge out the water, the air, sorry, you will be able to purge out the air inside the coil efficiently. So yun lang yung difference no, yun lang yung reasoning nun. Bakit inlet sa baba, outlet sa taas. Inlet sa baba so that you will ensure that your coil is filled with water and not with bubbles. What's the effect of the bubbles? If there's bubbles, which means there are areas that doesn't have any water, which means there are areas that there's no heat exchange going on. So, yun ha. Question? Question? If there's no question, I will continue. All right. All right. So ito yung usual configuration natin. Filter unit, after the filter module, meron tayong coil, hihigupin ng fan, tapos itapon niya. So ito yung coil natin. Usually, pag-i-issue, cooling coil. Pero, pwede rin namang merong heating coil. So, filter, cooling coil, heating coil. Bakit ka nagkakaroon ng heating coil? Heating coil so that you will be able to reach the required humidity requirements ng room ninyo, especially kapag ka merong kapag ka low load, halimbawa sa air requirements mo tsaka sa heat load mo hindi nagtutugma. So this heating coil will give you artificial load so that you will be able to reach your design room conditions. Sometimes tatlong coil pa sila. Sometimes dalawang cooling coil. Meron kang pre-cool, saka meron kang cooling coil. Bakit may pre-cool ka, saka yung main cooling coil? Sometimes sa lamig na kailangan mo, hindi inaabot ng delta T. So usually yung delta T ng isang coil 5 degrees. So 5 degrees delta T, pero dahil sa kailangan mo ng more than 5, so nagkakaroon ka ng two-step cooling. So example niya sa mga laboratory, sa mga hospital, that they would require very low temperature. Kaya sa mga planta na kailangan ng low temperature, so nagkakaroon ka ng two-step cooling. Sometimes din, meron pang three-step. So pre-cool, cooling coil, tapos may heating na naman. So again, same as sa previous, yung heating coil is for you to be able to generate artificial heat to reach your room conditions. Meron pa silang, meron akong arrow dito. This is part of the run around coil. So yung heat na pumasok dito will be cooled, and this energy that was cooled will be given back to the air and will be heated up. So you'll be able to reach your desired room condition. So ito yung isang example, So ito yung filter unit niya. Meron siyang coil dito, merong coil dito, merong coil na naman dito. So assume na ito yung cooling coil, pre-coil, meron na naman siyang main cooling coil, at tapos meron siyang heating coil. Ito yung example ng AHU na tatlo yung coil requirements niya. Okay. After ng coil, saka before ng coil, meron tayong nilalagay. So first na accessory na nilalagay natin sa coils, is tong UV light. So naglalagay tayo ng UV light. So Kung makapansin nyo dito, no? Balik tayo dito. Oops. Ayan. So, ito yung coil section, ito yung fan section. Sometimes, in between dito sa filter section at sa cooling coil section, in between here, naglalagay tayo dito ng UV light. Balik natin yung UV light. Alright, ito yung UV light. Para saan itong UV light? Yung UV light is to kill the bacteria on the air. So, yung COVID-19, no? Ayan, pagka naglagay ka ng UV light doon sa AHU mo, namamatay yung mga viruses. So, viruses, bacteria, germs are killed via the UV light. And the UV light are usually installed after the filter, before the coil. Okay? Why is it so? After the filter, paglabas ng hangin from the filter, the bacteria will be killed here pa lang before it touches the coil. What does it do? By doing so, you'll be able to prevent or minimize the growth of bacteria doon sa coil mo, minimizing or lengthening the requirement of the coil to be cleaned. So nagiging mas matagal na malinis yung coil kasi wala lang ang bacteria, wala lang ang viruses. Kaya nanatiling malinis yung coil. So yung frequency ng coil mo para linisin, humahaba. Usually, no, sa mga AHU, the coils are being cleaned once a year. So dahil sa meron ka ng UV light, it will go to 1 year and 3 months or sometimes 1.5 years bago mo siya kailangang linisin because of the UV light. So the air quality, because of the UV lights, the air quality improves, the viruses, bacteria, and germs are killed, and your coils are preserved longer. Okay. So this UV light again is installed after the filter section, before the coils. After the coils, meron naman tayong humidifying section. So sometimes, no, we need more humidity. Halimbawa, tulad nung semicon manufacturing plant na didesign namin. So dahil sa temperature requirements nila, our dew point temperature is very, very low. Dahil very, very low, lumalabas sa amin na yung room condition namin, although we are heating the correct room temperature, but the humidity is very low also. What is the one effect of low humidity is static electricity. So nagkakaroon ng static electricity dun sa room. So one way to avoid that is you humidify the air. So you increase the humidity in the air. How do you humidify? You spray water. So and the spraying of water is done after the coil. All right. So before the coil, there's the UV light. After the coil, there's the humidifier. This is where you install your coil accessories. Okay. Question? Wala pa? So kung walang question, dito naman tayo sa fan selection. So ulitin natin, no? Kanina meron tayong filter section, yung filter natin, pre-filters and bag filters. After nung pre-filter bag filters natin, meron tayong coil section. Now, punta naman tayo dito sa fan. So, hindi natin pag-uusapan ngayon how to size the fan, but we're going to see what types of fan are installed inside the AHU. Okay. So basically, there are 3 types of fans that can be installed inside an AHU. First type, centrifugal. So centrifugal, ito yung most common na makikita yung configuration of fans inside an AHU. Meron tayong centrifugal fan, tapos yung fan is connected to a motor via a belt. Okay. Why does it so? Bakit mo kailangan lagyan ng belt yung fan at saka yung motor? Okay. Nilalagyan mo siya ng belt kasi yung fan has a different rotation requirement than the motor can give. So example, yung motor mo, no, 1,444 RPM. Yung fan mo kailangan lang ng 1,000 RPM. So how do you reconcile the rotation speed of the two equipment? You put a belt. You put a pulley system. So yung dito sa maliit, dito malaki. Ganyan. So the rotation here will still be 1,044, but because of the bigger plate here, bumabagal yung rotation niya. Parang bisikleta lang kumbaga. Diba sa bisikleta natin, yung sa may pedal malaki, so sa likod maliit. Diba? Ganun lang din yung principle nito. Yung dito, yung laki at liit ng belt and pulley natin will be dependent, can be calculated through the speed requirements of your fan. Okay? So you would have, so you will be able to reach the required frequency or the required speed of the fan according to your requirements, according to your flow and pressure requirements, through the belt and pulley system na ginagawa nitong motor na to. Yung motor natin, no, fixed speed yan eh. Fixed speed, dahil sa fixing speed niya, iba yung speed requirement ng fan natin, naglalagay ka ng belt and pulley. So kapag commander na yung fan, halimbawa ito, meron din siyang belt and pulley, no? So kapag commander na yung fan, itong fan will create a negative pressure, will suck the air in. So it will suck the air here, passing through, it will suck through the filters, it will suck through the coils, and it will be sucked by the fan, and then it will be expelled by the fan. Okay. Ngayon, meron pang isa. Dito, magkahiwalay sila. Ito, magkahiwalay sila, nagdikit sila via pulley. Okay. Next, configuration ng fan. Yung fan mo, yung centrifugal fan mo, kinabit mo diretso. So, ano mangyayari nito? So, ibig sabihin, yung rotational speed ng motor will be the same as the rotational speed of your fan. But if your fan has different rotational speed, how will you reconcile the two? These two are reconciled by using variable frequency drive, VFD, or variable speed drive, VSD. So you will use your VFD or VSD, no? I will use the term VSD. By using VSD, variable speed drive, to your electrical connection to the motor, you will be able to manipulate the frequency, the rotational speed of your fan, of your motor, and in turn, directly connected to your fan. So nakatipid ka ng nakatipid ka ng belt and pulley, nakatipid ka sa equipment, nakatipid ka pa sa maintenance. The belt and pulley system, no, you have to realign and adjust every now and then. Every maintenance period, no, you have to check, align, laser align, check the tightness of the pulley, replace the belt. But since na dito, coupled na sila, nawala na yung requirement na yon. Assuming that this motor is equipped with your variable frequency drive. So, hindi na siya, the speed of the rotation is not controlled mechanically. The speed of rotation is controlled electrically. Yeah. Okay, one more. Yung fan natin, no, pinag-usapan natin kanina, the fan will be creating a negative pressure. So, dito sa portion na to, yung air papasok dito sa butas na to, dito sa gitna. Papasok sa gitna, and then it will be expelled out sa nozzle, sa face niya. So, ang tawag dito is single inlet, kasi isa lang yung butas, single width, isa lang yung width niya. Same as this one. Ito, double inlet, papasok dito, papasok din sa kabila, double width. Dalawa din siya doon, no? May hati siya dito sa gitna. So, dito ngayon kakabit yung motor mo. So, depende sa requirements mo, depende sa fan selection kung double inlet, double width, or single inlet, single width. So, single inlet, single width, syempre, mas konting airflow, double inlet, double width, mas madaming airflow. Syempre, ang nun is, the bigger your motor is. Ano naman mangyayari kapag kinabit mo yung HU, makikita mo dito, ang orientation niya sa ibabaw. Sa ilalim yung motor, sa ibabaw yung buga, pag ganon. it doesn't really matter, no? But you just have to specify to your AHU manufacturer kung anong configuration ng fan mo. Whether pag ganito, o pabugas sa taas. So ito yung ito yung 4 main configuration ng AHU. Pataas, pababa, paharap. So it doesn't really matter, but you just have to specify kung pag ganito ba yung configuration, pag ganito at pag ganito. Ano yung difference nito? Bakit kailangan mong i-specify na pag ganito, pag ganito, pag ganito, o pag ganito? Right. Pag ganito yung configuration ng fan mo, pag ganyan, ibig sabihin, padiretso siya. Pag ganon. Okay? Pag naman pag ganito, ibig sabihin, pataas siya, tapos kakanan. So, yun yung main nung kasi paglabas ng hangin dito, medyo turbulent pa siya, ang tendency ng hangin ay kumanan. So you would specify na pag ganito yung orientation ng fan mo, pag kanan yung paakyat, tapos kakanan yung hangin. Pag pakaliwa naman, syempre pag ganito, pakaliwa. Okay. Sometimes kasi, yung hangin, pwede rin pababa. Pero hindi naman tayo nagbubutas ng AHU, no? So ang mangyayari, pahalang muna bago bababa. Okay. So ito yung configuration mo. Ito, bihira. Bihira kasi hindi naman pwedeng lalabas ka rito sa akyat. Hindi naman pwede yun. Hindi dumiretso ka na umakyat. Ha? So ito, bihirang-bihira. But this is also an option. Pag diretso lang pahalang, usually, ito yung ginagamit natin configuration. Diretso pahalang. Dahil sooner or later, yung pahalang na yan, so pagdating sa terminal units, bababa yung hangin. Kaya ito pa rin yung ginagamit natin. Ito, ginagamit natin pagka mga under raised floor o sa ilalim yung buga ng hangin. So pag buga ng hangin sa ilalim, aakyat naman yung hangin na gano'n. So ito yung configuration na ginagamit natin. Pagka yung buga ng hangin sa sahig, under raised floor. So these are the 4 main configuration of your centrifugal fan. Okay. So ito yung fan, no, yung fan housing, ito yung fan blades, ito yung fan inlet. Okay. Ano naman mangyayari ngayon kung tanggalin natin tong fan housing? Tapon na natin to, wag na to, sayang lang yung materials na ginamit natin dito. Ang mangyayari niyan, ganito na siya. Ang tawag dito, plug fan. This is what is called now a plug fan, where you don't have this housing anymore. So actually, the plug fan is also a centrifugal fan, a direct coupled centrifugal fan, without his housing. Why is it so? O balik tayo dito, no? Okay. Ngayon, ang mangyayari dito, kapag hinigop na yung hangin dito, ang mangyayari, the air will be thrust here. Diretso tapon palabas. But if you use a plug fan, okay, what will happen is, yung buong fan casing assembly mo will be pressurized and it will naturally push the air aside. So yun yung premise ng plug fan. And if you use the plug fan, ang mangyayari dyan, you would have a cheaper fan kasi wala ka ng housing. Direct coupled ka. So parehas lang ito, no? Parehas lang ng ganito. Ganito siya. May fan, may motor, tinanggal mo lang yung housing. Kaya sa tinanggal mo yung housing, you're not limited to the configurations anymore. It doesn't really matter where your AHU opening is, whether it be sideways, topways, frontways. Doesn't really matter anymore when you are using the plug fan. So using the plug fan, the fan will be more cheaper than your standard centrifugal fan coupled with your motor. Ang limitation lang ng fan mo is you're always direct coupled with your motor. So you would need electrical controls, yung VSD mo tsaka yung VFD. So ito yung isang example kanina, no, nung plug fan natin. So yung plug fan, so makikita mo dito, sinarado niya, hinaus niya yung suction point niya. Tapos meron siyang isang opening para doon sa suction point niya. wala na siyang opening sa sideways, no, sa topways or sa bottom, no. So it will pressurize its whole section and pushing the air out. Ang kinagandahan pa ng plug fan is you can use multiple fans simultaneously. Unlike dun sa centrifugal fan where you can only use one fan for one HU. May question dito si Jordan. Jordan, can you unmute yourself? Hello, Jordan?
Sir.
Yes.
Paano naman ang efficiency ng plug fan compared sa sa may housing?
Ayun ang magandang tanong. Ang efficiency nila will be the same. Walang pinagkaiba because a plug fan and a centrifugal fan is actually the same equipment. So nakatipid ka lang talaga doon sa housing. Isa pang maganda dito sa plug fan, pwede kang gumamit ng mas maliliit na fan. Kasi doon sa doon sa centrifugal fan, you are limited to one centrifugal fan only. Pero sa plug fan, because wala ka nang housing, you can use smaller fans and multiple fans at the same time. Provided your electrical engineer is very good, no, to be able to calculate the electrical loads of the fans. Kasi kailangan syempre sabay-sabay ang pitik niyan. Hindi pwedeng umaandar to, ito hindi umaandar. So dapat equally loaded sila. So, ang mangyayari kasi niyan kapag ka maliliit yung fans mo, ibig sabihin maliit lang din yung draw ng electrical equipment mo. And you will be able to overall have a smaller electrical requirement compared sa isang centrifugal fan. So yung apat na maliliit na plug fan will have more electrical efficiency, will have higher electrical efficiency compared to one big centrifugal fan. Alright? Kapag ka ganito, this is considered a series connection. So the pressure drop of this fan is equal to the pressure drop of this fan, the pressure drop of this fan, and they're only increasing the flow requirements. So ito pa yung isang advantage niya. Kapag ka naglagay ka ng centrifugal fan dahil sa isang malaki lang siya, kapag ka nag-part load ka, halimbawa running only at 75% capacity, yung efficiency ng centrifugal fan mababa. Not unlike na kapag ka nag-plug fan ka, ito running at peak efficiency, off mo lang to. Yun lang ang mangyayari. So which means your electrical consumption or your electrical requirements will always be at peak efficiency. Doon ka nakakatipid ngayon. Kasi as a designer, no, we will always size up our equipment at the worst case scenario, at the highest requirement. But this highest requirement seldom comes about. So usually hindi naman tayo full 100% capacity yung HU natin. Usually it's part load capacity. 80% kadalasan, 80%, mataas na yung 90, 75%, between 70 to 80 yun yung usual na load natin. At that load, yung tatlong plug fans will be more efficient, will be eating less electrical equipment than one big centrifugal fan. So that's the advantage of using the plug fan, no? However, there's one more type of fan, easy fan. So yung easy fan naman, ito, makikita mo dito, ang motor na ginagamit mo dito, same as your centrifugal motor. The motor here is an AC motor or alternating current motor. Kapag ka nag-easy fan ka, makikita mo, lumiit yung motor. This motor now is using DC or direct current motor. So, from AC to DC. Ngayon, dahil sa AC motor ka, so these equipment are connected to central controller. Tapos meron kang individual VSD, individual variable speed drives for you to be able to control all these four equipment. And these individual speed drives has to be synchronized to each other. Hindi pwedeng nauuna to, tapos nauhuli yun. Magkakandaloko-loko yung fan speed natin, no? Hindi rin pwede na magkakaiba sila ng speed, running speed. So, kailangan lang is either pare-pareha sila o hindi gumagana. So, ito, kung gumagana yung kung ano man yung, kung ilan man yung gumagana, dapat pare-pareha sila ng speed, running speed. This AC fans eliminates the need for variable speed drive. Dahil sa DC siya, pwede ka na ngayon mag-input ng simple commands like 4 to 20 milliamps, and it will run according to the speed that you require. So para siyang variable speed drive, para siyang plug fan, well, hindi siya parang plug fan. Plug fan siya, but instead of using AC motor, you are using DC motor. So same principle, no? Apat dito dahil sa mas maliit yung capacity ng AC fan, mas marami siya. Mas maraming AC fan sa isang air handling unit. But still the same principle. Kapag ka-part load ka, kung ilan ang kailangan mo, kung meron kang siyam na fans dito, kailangan mo lang 6 ang gumagana, o di 6 lang ang gagana. Ganun lang din siya. So ito yung tatlong types ng fans sa loob ng AHU, no? Meron kang centrifugal fans, yung common natin, centrifugal fans with belt, centrifugal fans that are connected or direct coupled. Kapag tinanggal mo yung housing ng centrifugal fan mo, magiging plug fan ka. Ito yung second type, plug fan. Cheaper dahil wala ka ng housing, and you'll be able to install multiple fans in one AHU, making your electrical consumption efficient. At yung third is plug fan, but instead of using AC electrical current, you're using DC to remove the requirements of a variable speed drive. So this is ito na yung mga bagong AHU na lumalabas ngayon, no? Naka-AC fan na sila. So sa amin, no, sa company namin, one of our business strategy is to convert the old centrifugal belt-driven fans. Meron pa, marami pa. There are still those 10, 20-year-old facilities that are still using centrifugal fans with belt-driven motors. And our company, what we do is we propose to the client to replace them with these AC fans, which are more energy efficient. So ang kontrata namin sa kanila is for the next 5 years or for the next 10 years, yung difference ng electrical consumption ng AHU mo sa amin. So ganun yung kontrata namin. So we would assume na these fans would pay itself in 5 years, in 6 years. So the installation will be actually self-financed. So what more kung yung new installation mo ang nakalagay na AC fans? So that's it. So ito yung difference ng AC fans saka ng plug fans, no? So same principle sila. Ang difference lang is itong itong variable speed drive na wala yung requirements ng variable speed drive because you are using AC motors or direct current motors. So ito yung isang example ng isang installation ng mga AC fans. Last module sa isang AHU is yung economizer. Ano yung economizer? Economizer is to economize or to more efficiently use the cooling that are being done by your AHU. Now, cooling air is a very expensive business. Malaking energy ang ginagamit natin for the air to be conditioned to our liking, no? And it's a pity sometimes to throw those cold air away. So that's why we have economizers. So the two types of economizers that are common in our day is the rotary wheel heat exchanger or the heat wheel and the plate heat exchanger. So how does these things work? First, yung heat recovery wheel, ito or heat wheel, ito yung heat wheel. Isa siyang malaking gulong, rotating body. Okay? So, ang principle natin is yung outside air, okay? Yung outside air magiging supply air at yung return air itatapon, i-exhaust. Dahil itatapon mo to, sayang naman yung lamig nito. Yung lamig nitong return air is nasa, sabihin mong yung design condition mo is 24 degrees Celsius. Yung outside air mo sa Pilipinas is 34. Sayang naman yung lamig ng 24 kung itatapon mo na rin lang naman, di ba? So what does this do is there's a rotating body here. This body is composed of gels or silicones that can easily transfer the heat. So once the silicone is here below, this return air will cool up the silicone or will cool up the medium here. And since it's rotating, this medium will soon go up. And this cold medium that will absorb the heat from the outside air. Okay? So yung 24 degrees Celsius mo na itatapon mo na siya kasi exhaust air na nga siya. Yung 24 degrees Celsius air na itatapon mo, the coldness, yung coldness noon, ita-transfer mo dun sa outside air na papasok. So ito, yung 24 mo, pasa mo yung lamig niya, ipapasa mo dun sa outside air na 34. So yung 24 mo, paglabas niya, 30 na siya, at yung 34 mo, pagpasok, ano na siya? 28. So yun yung isang yung isang effect ng heat wheel o ng economizer. So ngayon yung imbis na yung cooling coil mo will cool down 34 degrees to 12 degrees, 28 ka na lang ngayon, 28 to 12 degrees. So lower delta T. Because of lower delta T, you would require lower energy consumption. And that energy consumption now, the difference in energy consumption is saved because of this heat recovery wheel. Ang isang downside nito, no? For example, this return air, whatever particle or whatever contaminant this return air has, will likely be passed to this outside air because this return air will touch the medium, no, or yung kung naman yung umiikot dito, yung silicone na umiikot dito, no? And then kung yung silicone na yun, it will have in contact with the outside air. So whatever contaminant, whatever particle has returned air here will be transferred also to this outside air or supply air. Okay. So sometimes you don't want these particles or these contaminants to mix or to mingle together. And in doing so, nagkaroon tayo ng plate heat exchanger. Okay. So yung principle ganun pa rin, no? You want to transfer the heat from your outside air to your exhaust air. But at this time, there's no contamination, there's no transfer of contamination. So the exhaust air, the extraction air, no, to going to the exhaust air, will not have any direct contact, indirect or direct. There's no contact between the exhaust air to the supply air. So ang ginagawa niya, pinapalamig niya lang yung compartment niya at yung compartment niya katabi sa kabilang side is yung outside air. So nagkakaroon sila ng sa plate, nagkakaroon ng heat exchange. But the medium itself, the fluid itself, the air itself does not mix together. So the contaminants are not passed from the extract air, from the exhaust air to the supply air. So you have your plate heat exchanger. In summary, ito yung AHU natin. So AHU natin, ano yung mga components ng AHU? First, meron tayong mixing box. Dito pumapasok yung return air at saka yung fresh air. Naghahalo sila dito. And once they mixed up, they will pass through the filter section. Here in the filter section, there's your bag filter and your pre-filter. So dalawa siya, no? Sorry, hindi ko na-type. So there's a bag filter and there's a pre-filter. After the bag filter and the pre-filter, it will pass through the coil. So coil, marami tayong different kinds of coil. Meron tayong cooling coil, pre-cooling coil, run-around coil. So depending sa temperature requirement mo, no? Depende sa application requirements mo, how you will get your design condition. Before the coil and after the filter, sometimes you would need UV lights. After the coil, there will you put your humidifiers. After nitong humidifiers, meron tayong fan section. So yung fans natin, pwedeng centrifugal, pwedeng plug. Yung plug na hati sa dalawa, yung normal na plug fan using AC motor or plug fans using EC motor. Tapos after nung fans, if you have other requirements, pumapasok ngayon yung end filters mo. Dito papasok yung HEPA filters or your chemical filters. Question? Is there any question? Maraming salamat. No? I will stop my screen share. So you're free to ask question. Wala namang problema. For those who are asking, this session is being recorded. So for those who are here and those who have registered, I will forward you the slides and also a copy or a link to the recording. For those who are watching us via YouTube or via Facebook Live, just message me, email me, or contact me if you would require the slide. Okay. Question?
Sir, good evening.
Yes, Sir Eric.
Sir, yung sa economizer, sir,
Yes,
same
sir.
lang ba yun sa principle sa ERB? Mga HRB?
Sorry, ERB, HRB, hindi ako familiar.
Yung heat recovery ventilator, sir, yung sa mga kuwan.
Yes, same principle. Same principle. Parehong-pareho siya. Actually, yun. Ilagay mo lang sa loob ng AHU. So, ang advantage lang nun, it will be mas malaking quantity ng air ang hina-handle mo instead na yung ERV maliliit lang.
Thank you, sir.
Thank you.
Question, sir.
Yes, sir. Yes, Sir Calvin.
Yung ERV po ba is pinapower siya ng separate motor o by yung wind na lang nung supply tsaka exhaust?
Wala siyang power requirement. The heat exchange itself is without electrical or power requirement. The wind is being manipulated or doon sa pressure ng fan. So yung amount of wind or amount of air being or fluid being having an exchange is dependent dun sa fans na nakakabit sa kanila.
Okay po, sir. Thank you.
Okay, thanks. So kung if you're here sa Zoom meeting natin, no, so automatic nag-register kayo, kaya kayo nakatanggap ng link. So if you're registered, I will use the same email addresses to provide you the link of the recording and the copy of the slides. All right. Maraming salamat. Maraming salamat sa pag-attend niyo, no. So if there's no more questions, I don't think I would keep you any longer. Papaalam muna ako sa inyo. Thank you very much for joining us in this session of Even Learning. Next week we will be talking about fans and pumps. So, kung ano yung mga principles that are being used sa pag-select natin ng fans and pumps. All right. So, thank you very much. Thank you for a wonderful evening with you guys. I enjoyed being with you. And I will see you again next week. Okay. Thank you. Bye-bye.